Exercise 1002 is talking about how to solve simultaneous equations using the elimination method, which is one method. It's not my preferred method, but it can be easier at times. The reason why it's not my preferred method is it's not applicable all the time, whereas the substitution method can be used all the time. Sometimes it does get a bit more complicated though. So let's look at the elimination method. Remember, to solve simultaneous equations, the goal is we're given two linear equations, which just means they'll be graphed as lines, and we're trying to find the point at which they cross. Now, the point at which two lines will cross will have an x coordinate and a y coordinate, which we can see in the solution from the example, x equals 4 and y equals 1. The elimination method basically speaks for itself. You're aiming to eliminate one of the variables to work out the other one. Let's look at the questions rather than the examples. This is question 1, where it says, for each pair of simultaneous equations, eliminate one variable by adding the equations, then solve for the equations. So what we can notice in all of these examples is one of the variables has the same constant, has the same number before, which is 1, and 5h and 5h, and one is a positive and one is a negative. So we always go through the same steps with simultaneous equations. First, we label them 1 and 2. So whenever I write 1 in a circle, I'm referring to this equation. Whenever I'm writing 2 in a circle, I'm referring to the second equation. Now it's telling us to add the equations. So I'm going to write 1, because that refers to that top equation, plus 2. Now we just add the like terms. So 4k plus 2k, that's going to give us 6k. And here is where the elimination comes in. D plus negative d, they're going to cancel each other out, because 1 plus negative 1 is 0, 10 plus negative 10 is still 0. So they're going to go, and 5 plus 7, that equals 12. Now we can look at this and say, well, if 6k equals 12, to get rid of the 6, we're going to divide each side by 6. We're going to work out that k equals 2. That's half of the equation solved. The other half is to work out what d would equal. So to work out what d would equal, we have one of the solutions. We're going to take k equals 2, and you can put it back in either solution, in either equation, sorry. I would be tempted to put it back in this first equation because d is already positive, and that's what I'm going to try and work out. So I'm going to take k equals 2, and I'm going to sub it. So sorry, I should have written sub k equals 2 into equation 1. And all that means is anytime I see k, I'm going to write 2 in its place. So 4k means 4 times k. Instead of k, I'm going to put 2. So 4 times 2 plus d equals 5. 4 times 2 is 8, plus d equals 5. To get d by itself, we're going to subtract 8 from each side. So I'm just going to move that to the other side. I'm just going to write 5 minus 8. And d is going to equal negative 3. We should, in a nice solution, we should write at the bottom k equals 2, d equals negative 3. And that's it. So we add the two equations, we get rid of one of the variables, and then we solve to get k. We use that solution to go back and solve for the other one. I'll do 1b. So again, we label. I might use a different color. We label 1, 2. Always label. Again, we know we're going to add because the question asks us to add. So 1 plus 2. And when we add, we have 2x plus x. That's 3x. Negative w plus w, they're gone. 6 plus 9 equals 15. 3x equals 15. We know x is going to equal 15 over 3. X is going to equal 5. Now we have the solution for x. We're going to go back and solve for w. This time I'm going to use the second equation, not the first. because the second equation has w already being positive. And I don't have to do anything to the x. I don't need to times it by anything. So I'm going to sub x equals 5 into 2 this time. And that equation for 2 is x plus w equals 9. But instead of writing x, I know that it's 5. So 5 plus w equals 9. Now, to get w by itself, we're just going to subtract the 5. So w is going to equal 4. And that's our solution. X equals 5, w equals 4. And that's how we use the elimination method, by adding. To use the elimination method by subtracting, it's the same method. So here we're going to be subtracting. We're going to label them 1, 2, but now we're going to subtract them. So we're going to say equation 1 subtract equation 2. And when we go to do that, we'll see 5k minus 3k, that's 2k. D minus d, well, they're going to go, same thing, 10 minus 10 is 0, 100 minus 100 is 0, and 16 minus 4 is 12. So k is going to equal 12 on 2. K is going to equal 6. Now we have half the answer. We go back and find the other half. They're both positive. What I would look for here is probably the one with smaller numbers. So I'll use equation 2. It's not going to make a difference. You'll come up with the same answer. So sub k equals 6 into equation 2. And that's going to give us 3 times k. We know k is 6 plus d equals 4. 3 times 6 is 18 plus d equals 4. To get d by itself, we're going to subtract 18 from both sides. And 4 minus 18, that's negative 14. So our solution now is k equals 6, d equals negative 14. I'll do one more. I'll do c this time, space it out. Again, we're going to subtract. So we label first, always label. We're going to subtract, let's subtract 1 from 2. It does make a difference when you're subtracting, but it won't make a difference when you're adding, because if we looked at y, negative y minus 3y, so if we flipped it, I might list them both to show you what I mean. So let's start here, 1 minus 2. 4h minus h, 4h minus 4h, they're gone. 3y minus negative y. 3y minus minus, that's actually a plus. So that makes it 4y equals, and 24 minus 8, that's 16. So y is going to equal 4. On the other side, if I did 2 minus 1, it's starting from the bottom term and working our way up. 4h minus 4h, that will still cancel each other out. But negative y minus positive 3y, that's going to give us negative 4y. Sometimes it will be beneficial to do the bottom minus the top. And 8 minus 24 is negative 16. Now, the reason why you might want to go from bottom to top is to keep y positive. Now, in this case, y became negative, so it doesn't work here. But sometimes it might be better to go from bottom to top with this method. But we're still going to get y equals negative 16 on negative 4. Y equals still 4. So that's one thing that you need to consider. But I'll get rid of that. Let's keep going with this solution. We have y equals 4. I'm going to substitute it into 1 because y is positive. It's not negative. So sub y equals 4 into 1. We get 4h plus 3 times y, which is 4, equals 24. 4h plus 12 equals 24. I need to get rid of the 12 before I get rid of the 4. So I will take away 12, take away 12. So 4h equals 12. I'll divide by 4, h equals 3. So our solution is y equals 4, h equals 3.